Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human-Centric AI podcast, where each episode we feature thought leaders doing cutting-edge work in the AI space. A little bit about us. SmartEye is the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today, our technology is embedded in next-generation vehicles, leading the way towards human-centric mobility through driver monitoring systems and interior sensing solutions. Our research instruments offer unparalleled insights into automotive, aviation, assistive technology, behavioral science, and many more fields. Today's episode features Dr. Bryan Reimer. He is a research scientist at the MIT Center for Transportation and Logistics and MIT Age Lab, specializing in driver safety and mobility. With extensive experience in driver behavior research and a multidisciplinary approach, Dr. Reimer's work addresses the challenges of driver attention management, distraction, automation, and advanced driver assistance systems. His research informs technology development, business strategy, and public policy, making him a leading expert in the field. Bryan and I talked about the latest advancements in mitigating driver distractions through improved driver support, highlighting the role of vision sensor technology in enabling OEMs to make better decisions in supporting drivers. He emphasized the importance of effectively utilizing the information collected by driver monitoring systems to enhance driver support and provided examples of positive reinforcement techniques that can positively impact driver behavior. Let's listen in to learn more. All right. Hi, everyone, and thank you for joining us today. With me, I have Bryan Reimer, PhD from the MIT Age Lab. Bryan, thank you so much for taking the time to speak with me.
Happy to be here.
Awesome. So we've actually had you on the podcast before. It's been a while, though. So I know we worked together a lot when we were big in automotive at Affectiva. I had you speak at our summits, Emotion AI summits a few years ago. But for those who don't know, can you briefly tell us about your background to start? How has your career path taken you to MIT?
Sure. About 20 years ago, I did my PhD at the University of Rhode Island, looking at some of the first eye movement studies of drivers leveraging cell phones and other technologies in vehicles. In essence, the early days of leveraging in-vehicle data recording to look at driver attentiveness in the real road. Over the past 20 years at MIT, my career has taken me from heavy work in driver workload, driver distraction-related issues, driver monitoring in its infancy a decade or more ago, when we were thinking about many of the applications that we're seeing in reality today, over to the study of many of the advanced vehicle technologies around active safety, assisted driving, and automated driving that are out in the world today. And I do a lot of thought leadership work around the future of mobility and how automation may be reshaping how we live and move in the decades ahead.
Mm-hmm. Absolutely. So can you describe your research scientist role at the Age Lab? Can you share a bit about, what you're working on?
So within my role at MIT, a good deal of my effort at the moment is around the Advanced Vehicle Technologies Consortium, which I founded in 2015 as an academic industry partnership to bring organizations together to look at real world driving data to better understand what technologies are being used in the real world, what technologies aren't being leveraged quite as effectively, and to begin to work as a community together to understand the unknowns around how automated technologies, active safety systems, and other in-vehicle technologies are being used in the real world. The key here is that the complexities of our transformation and mobility enabled by automation and lots of those sensing technologies are so fast and furious and so cumbersome to understand that working together is the only way as a community auto safety organizations are actually going to derive the insight that's needed to accelerate product development in ways to support consumers' well-being and interest in convenient, comfortable, safe mobility.
Yeah, so I was wondering if you could talk through some of the latest advancements that you might have seen recently in mitigating driver distractions through better driver support.
So when we look at within AVT, we have the benefit of being able to compare and contrast and do very interesting apple-to-apple comparisons between different production systems. So we can look at how vehicles like GM's Cadillac CT6 equipped with Super Cruise, which is an automated or hands-free driving feature, with a fairly robust developed driver monitoring, driver support strategy, compared to technologies like autopilot that exist with much weaker driver support systems.
Mhm.
And we can begin to look at, the differences in what people do and how their attentiveness to the road changes. And you're just starting to see some of the tipping point of that come out in the public domain. While internally to the consortium, we're comparing, how different non-driving related activities are executed, how they're threaded with the automation systems and different road contexts, where people choose to do things, how they transition to and from the automation. Some of our most recent research that's public, begins to characterize this around a certain vehicle. So, for instance, a paper that came out a few months ago around system-initiated transitions of control with Cadillac Super Cruise, looks at how fast folks in the real world return to active steering when the automation system says, "Hey, it's time to drive now." And we see it takes about 2.4 seconds to get active steering applied on average when both hands were off the wheel prior to the transition request, and about 1.9 seconds when one hand was on the wheel. Again, people are engaged in different activities, changing the characteristics of the transition. So when we think about attentive driving, we can also begin to look at eye movement data and begin to understand how people are leveraging their attention and allocating that to the road and different activities in the vehicle. So, the vast majority of glances when using autopilot are exceeding traditional long glance duration characteristics of 2 seconds. Not surprising, when automation is there to support us, we begin looking away from the road for longer periods of time. Now, is that a good thing or is that a bad thing? Well, that's an interesting question because, why are we automating? We're automating to free resources to do other things. This isn't new. Power steering, automatic transmissions are just the early stages of automation. When you remove the need to monitor the transmission, push the clutch, move the stick shift, we free the hands to do other things. And what do? We pick up the phone to talk to people. We pick up the phone to text in ways that we really probably shouldn't.
Yeah.
But it's automation 101. So when we begin to bring more automation in, hey, we can do more. Now, the key is that over the most recent few years, we're capable of using driver sensing systems, such as those pioneered by Affectiva, Smart Eye, and others, to monitor the driver, fuel algorithmic developments on how to interpret what the driver may or may not be doing, and support driver feedback or driver support systems. So, in essence, we're capable of doing a lot of what we were once perceiving to do on the external world, sense what's going on, make a decision on where I want to go from a path, and activating, the vehicle. We're capable of doing some of that and supporting the driver. And the real interesting systems are the systems that are beginning to think about how do you fuse active driver support together with assisted driving features so that they're working collaboratively together to support safer, more convenient mobility.
Yeah, and I wanted to ask in terms of driver monitoring systems, and you might have touched on this a little bit, but I want to give you opportunity to expand. What do you believe is key for utilizing information collected, and how can this information be effectively used to enhance this driver support?
Okay. So first of all, I think that the most important piece of information we can get today from driver monitoring systems is attentional information around the driver's eye movements around the road. Lots of other features we can think about, whether that's emotional state, whether that's alcohol, whether that's, different measures of fatigue and impairment. But the key it starts with is where are the eyes looking and how often are they focused on the road or areas of interest away from the road? Because at the end of the day, as drivers, if we aren't attending to the situation around us adequately, we're not going to respond to threats out there. So it really starts with not what am I doing? It starts with where are my eyes? Now, we can fuse and support that more copacetically with other information. So if you're looking away from the road and you're looking at the center stack of the vehicle, where the information may be a little more easily to modulate by the vehicle systems, that's different than looking at the smartphone where we have no ability to modulate that. And we can begin to think about support systems that differentiate when I'm looking at information that can be suppressed at a point in time or information that can't be suppressed at a point in time. But really, at the end of the day, it starts with eye tracking and eye movement behaviors. And this is stuff we were working on in the research lab 20 plus years ago.
Yeah.
It's just the quality of what we can sense in the vehicle is far better over the last decade or so than we could ever imagine 20 years ago.
Right.
And we are now at the point where we can get real-time systems from a vehicle that are fast enough to model, modulate, and use to provide feedback to the driver on how to do things better. In essence, providing a subtle tap on the shoulder through, an icon change or illumination change or a salient cue to, hey, maybe we should be paying attention to the road a little more right now.
Yeah. Yeah,
Okay.
definitely.
So it's the fact that we can now do things in real time using advanced AI that were, on the drawing boards in the dreams a
Yeah.
decade or two ago.
Awesome. Awesome. So, in prior discussions we've had, you've mentioned the importance of positive reinforcement in driving support systems. Can you elaborate with some examples of what this might be that you have seen and maybe the potential impact that it can have on driver behavior?
Yeah, a lot of folks really, think about, well, we need to make sure the driver doesn't do what they're not supposed to do, in essence, chastise them for doing what they know they probably shouldn't do otherwise. And
Yeah.
I'm one, and many others out there believe in the power of positive. If we want to change behavior for the positive long term, we need to get people to trust technology, be encouraged by technology, wanting and desiring to do better.
Mhm.
Now, we as humans very often don't react so well to negative chastising behavior.
Yeah.
So when the alert goes off in the car, it goes, we don't like to hear that. I know I should be doing this anyway. This is really annoying. How do I pull the fuse or how do I shut this system off? I don't want to be annoyed, and I don't want everybody else in the car to know I'm not doing what I should be doing.
Yeah.
So if we look at systems like GM Super Cruise, which use a high mount illuminator on the top of the steering wheel, flashing a green light when you're not looking at the road enough, a quiet, subtle, positive reinforcement to be doing what you should be doing, looking up.
Yeah.
Yes, when that doesn't work, we often see a cascade of alerts and alarms that move from positive to more negative in terms of their interpretation as the situation gets more complex and perhaps more safety relevant. But if we just subtly tap people on the shoulder, hey, you should be thinking about this, you should be doing this, how do we begin to encourage the appropriate behaviors over the long haul?
Yeah.
How do we encourage folks to adapt to behaviors that they know they probably should be doing, but we often just forget because the heat of the moment, I'd like to finish searching for that radio song that I want to listen to. Hey,
Yes.
remember, you need to look up now. So I think that when we think about driver support systems, these systems have to be highly in tune to who the individual is, the context that we're driving under. All this is stuff that we can sense now. We can bring into more advanced management approaches. We can use very simple LEDs in the vehicle to encourage people to look in different locations when they need to. All of this can be done in real time and done, in a way that aims to develop a deeper collaboration between the operator and the automation and support systems that are there.
Mhm. Absolutely. So the driving experience has evolved significantly over the years. How do you think we should reimagine the role of drivers and their needs in today's, more technologically advanced vehicles, and how might we or how can we adapt to these changes effectively?
Actually, that's a good question. I think the reality of driving has changed a lot over the last, several decades. We are not the drivers we were in the 1950s, where you needed two hands on the wheel and all your muscle and might to get around a curve.
Yeah.
And at the end of the day, we need to get out of the misnomer that automation is new. It's not. Automation, sensing, and support, have been here for some time. As I mentioned earlier, power steering, automatic transmission. These are the tipping points in how automation began to change how we live and move. It
Yeah.
freed resources. So all we are on is a very, very deep and slippery slope of how automation is relieving workload more and more in the vehicle.
Mhm.
So when we think about the future, I think we need to reimagine what the driver's role becomes. Yes, it is a collaborator, it is a supervisor, but the driver needs to be attentive and responsible. And we need to make this very black and white. When you are in the driver's seat, you are responsible for safe mobility. And we can begin to re-envision how driver support systems are created to mitigate the vast majority of human error that leads to accidents. In essence, instead of focused on how do we build sensing to drive the car alone without the driver, much like the aviation industry discovered in the early 80s, we can use driver support features, training features, all of this to support the operator to be a better collaborator with the automation. Hey, humans are long known to be terrible overseers of highly automated systems.
Yeah.
There's a reason drivers need support. You know, we need to be given a little power, a positive, to be doing what we probably know we should be doing anyway, but often at the moment forget because, hey, we got multiple demands we're trying to meet at any given point in time. So what do we want driving to become? We want driving to become more convenient, more comfortable, and most importantly, safer. And how do we use driver support systems in particular, fueled by our ability to sense and monitor? How do we use driver support systems to really encourage people to develop skills that they're losing in situational understanding, skills to look at the road in the way they need to? You know, in essence, let's use the AI to enhance human expertise.
Absolutely. Now, when you're considering the global market, you know, what are your thoughts on standardizing automotive technologies to make them more accessible and cost effective for consumers worldwide? How can policy play a role in driving these standardizations?
Yeah. So when it comes to policy, I'm a firm believer that long-term standardization is a problem.
Yeah.
And once we draw a line in the sand in policy, we rarely move that line far enough forward fast enough. You know, we create a standard, it sits for 20 or 30 years. Let's think of backup cameras for a moment. Great research was done to justify backup cameras, but a lot of people are backing up vehicles now, trusting the driver support system, the camera and the sensors, as they were, you know, providing a complete picture of what's going on around the vehicle. The reality is that this is meant to be a information source to combine with what's going around when I turn around and look behind me when I'm backing up the vehicle. So, you know, we got to think about, you know, how these standards need to evolve over time. And you know, I don't really want to go into, you know, what my perceptions are where, you know, backup cameras need to move right now. But when we think about, once we draw a line, we rarely move that line. But we think about organizations like Euro NCAP, IHS, or Consumer Reports that are drawing a goalpost and willing to move that goalpost forward as we get better. We can be thinking about developing guidelines that are the best state of practice as we know it today, aiming to move the industry forward in developing a convenience feature or a safety feature to a point, and then that goalpost is going to move further forward, much like CAFE has moved fuel economy standards forward over the last several decades. So with that said, though, I do believe that harmonization between the U.S., Europe, and perhaps at times Asia would reduce the cost point of the technology by simplifying, you know, design development features across the continent. You know, while what works perfectly in Europe might not be the answer for the U.S., the reality is if we can simplify product, you know, the reality is instead of parts costing 2x, we can get them down to 1x, and we can get them impacting and deployed on a larger number of vehicles faster. You know, even basic driver sensing and a very basic driver support system, you know, is going to improve safe mobility quite efficiently. But we need to learn from that, adapt forward globally, and begin thinking about, you know, we as humans aren't the same as we were yesterday. We're not going to be the same tomorrow as we are today. We need to be thinking about how do we collect that data and how do we continue to augment things forward as we become more and more comfortable with this idea of automation supporting us at various times.
Awesome. Very cool. So to shift gears, pun intended, I understand that, you know, you might be working on some exciting projects that aren't yet public, because you mentioned earlier you have some papers that just came out. While you may not be able to share specific details, could you give us a glimpse into some of the areas or the trends that you're currently exploring?
So we're exploring trends and, you know, how different driver support systems, different automation systems are shaping driver behavior, kinematics, you know, non-driving related tasks, speeding. You know, as I mentioned earlier, you're starting to see a few papers come out talking about behavior as one system. The real art of the consortium at the end of the day is the ability to look at comparative data across systems. And one of the promises that we made to the supporters of our work is that, look, you know, we're going to deliver what we know in real time to the members that are supporting us. And as it gets through the publication process, which naturally delays things by months, if not years, we'll share some of this with the outside world. But the key being is that we need to ensure that the 25 or so companies we're working with have a competitive advantage of knowing what's going on out there that we're observing today, having the ability to react to that, having the ability to operationalize decisions on that, in advance of the general public. So we really begin to see at this point a number of the companies we're working with having sizable competitive advantage in both the data we're delivering and the insight we're delivering and what they're learning from each other. One of the most powerful things from ABT is that we have organizations talking about research in ways that just have not existed in the auto safety environment, convenience technology environment in the past. It's amazing how much folks can learn from each other under an MIT umbrella with some neutral data out there that motivates discussion. And I think we're finally crossing that tipping point here where folks are learning a ton from each other, and it's promoting some smart product decisions. Engineer pushback in terms of marketing at time, but helping shape more strategic product decisions down the road.
Mm-hmm. Yeah, and you jumped ahead to my next question too, but just so to reemphasize for listeners, so the MIT AVT, so the Advanced Vehicle Technology Consortium is what you're referencing. Yep. There's over 25 companies involved. Any significance of this collaboration or how it's influencing the way people use automotive technologies that you want to expand on in addition to what you've already shared?
I don't think it's influencing how people use automotive technologies. It's influencing how the design engineering team understand how people are using these technologies. Every OEM out there has long benchmarked what components are in each vehicle. They know what radar each manufacturer is leveraging in each platform. The real art isn't what radar or what parts are being used. The real art is how is all this coming together in a system to shape human behavior in a way that promotes, positive, convenient, comfortable, safe mobility. So I don't care what tires you put on the car. That's a performance decision the OEMs need to make. The end of the day is, are the tires you're putting on the car shaping behavior and how you drive and how you navigate differently and imparting a different behavior on the consumer?
Definitely. And as someone deeply involved in the field of AVT, what are your thoughts on the importance of organizations actively participating in these advancements? What benefits do you see in terms of, the collaboration and the knowledge sharing?
So I think that's really the key, Ashley, is that the collaboration to support mutual interest when, you have 25 different organizations, each putting in a little resources that come together, you now have a fairly substantial research program that is developing data that they're all using collaboratively and then discussing that provides a significant market and competitive advancement to the organizations involved. The dream when we built AVT was to create a organization that developed data, analyzed data, shared that data to motivate product decisions. It's not just for the research. We want organizations to be best equipped to make stronger product-oriented decisions that reshape how we live and move over the next 20, 30 years. And, as organizations work together, look at data together, you know what? They learn from each other. I've seen stuff like this. Yeah. The collaborations are priceless. Mm-hmm. So, for the organizations involved, I think they're gaining significant market capacity, market extension. For the organizations that are not involved, I think they're losing insight that their, fellow organizations are gaining together. Mm-hmm. Mm-hmm. And I get the lucky seat of seeing some of this going on around us and seeing the bright lights go on around our sponsors when, hey, that can help me in my job and my role. And that can help us think about a new design challenge we have.
Awesome. Very cool. So we've covered a lot of ground today. I don't know if there was one specific takeaway from our conversation that you would like to leave the audience listening.
So if I had to think about a takeaway here, one key piece is that we've been pursuing automation to replace the driver for several years now. We still see a number of organizations that are aiming at that, and that very well may come to realization over at scale in the years ahead. But I think it's going to take a long time until there's a profitable business around highly automated mobility. Okay, hopefully it keeps growing in that direction. Mm-hmm. But for a while, we were firmly aimed at replacing the driver. Much like the aviation industry in the early 80s believed we had to get the pilot out of the cockpit. Mm-hmm. But what the aviation industry recognized in the mid to late 80s was that pilot error human error was a symptom of some more systemic problems. And I think that we have finally crossed the point where we're starting to get a grasp on that in the automotive space. Mm-hmm. So one thing I'd like to leave the audience with is the power of driver support systems to provide real-time feedback, encouragement to operators to do better is an area where I think we will see explosive growth in the decades to come. In essence, we're not going to replace drivers on the vast majority of the miles traveled globally. But what we can do is focus on mitigating those human errors through more proactive support, proactive management, and collaboration with the automation over the long haul. And the organizations that begin to work together across the supply structure, work with insurance partners, research partners, each other, are probably going to be the organizations that excel at providing more positive, penetrating product to market.
Great. Well, that's all I have for you, Bryan. It is always a pleasure. And thank you so much for speaking with me today.
Fantastic, Ashley. Have a great day.
I thought the discussion surrounding the evolving role of drivers in today's technologically advanced vehicles and some effective ways to adapt to these changes was fascinating. I really appreciated Bryan summarizing a key takeaway for our audience, urging active participation in the advancements of driver safety and emphasizing the benefits of a collaboration and knowledge sharing within the field. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We're also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag Human Centric AI podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.